Okay, for today's lesson, we're going to be reviewing some of the topics of Chapter 8, and then I'm also going to introduce compound interest. So this video is very important for you to watch, take notes on. If you have a printer at home, please print this out so you can do it. Otherwise, just do it on a separate piece of paper. Okay, so first of all, we have some exponents to simplify. So here I notice that the only variable I have is the letter n. Okay, so first we want to start simplifying this. I'm going to write this down here. 3n cubed. Let me make my line a little bit smaller. So we have 3n cubed times 3n to the 0 power. So this 0 power has to be distributed in to each of those terms there. So now we have 3n cubed times 3 to the 0 power and n to the 0 power. Now I want you guys to remember that anything raised to the 0 power is 1. Okay, so this becomes 3n cubed times 1 times 1. 3 to the 0 power is 1, n to the 0 power is also 1. So 3n cubed times 1 is just equal to 3n cubed. This 3 is only attached to the n. There's no parentheses like this, right? There was nothing like that. So this is your final answer. It's C for number 1. So it's very important that you look over your exponent rules. Don't forget that I did post extra videos on exponents and how to simplify exponents in Google Classroom. So make sure to use those videos and take notes to help you practice how to simplify exponents. All right, now this one is another power raised to a power. So this 3 on the outside here needs to be distributed to each piece inside. Okay, so this becomes 3 to the 3rd power times b to the 3rd power, and then times another b that was already raised to the 3rd power, so now I multiply to raise it to another 3rd power. Okay, and we went over all of this in class, how we would expand it and whatnot, so make sure that you do go back through class recordings and the videos that we've watched whenever we focused on Chapter 8 exponents, and that will help you remember why we do some of these. So now we can start to simplify. So I'm going to take this and just rewrite it down here. I like to show my work underneath it so you see exactly where I'm getting them from. So here I have 3 to the 3rd power, 3 cubed. You can put it into a calculator. Okay, so if I go to Desmo's calculator, I can put in 3 raised to the 3rd power. That is 27. You might also realize that exponents tell us to repeatedly multiply the base by itself that many times. So 3 to the 3rd power means I need to multiply 3 by itself 3 times. And you should still get the same answer, 27. Do not hesitate to use a calculator like Desmo's to help you simplify those constant terms here. So this is 27. This here is still b to the 3rd. And this one, 3 times 3 is 9. So now we have b to the 9th power. And we are still not done yet. So now that I have b to the 3rd times b to the 9th, that is the same base, I can combine those two. So if I were to write this all out, it would look like this for this one, and then this one I'd have to write them out 9 times and so on, right? But we learned shortcuts where we can use our product rule. So this is equivalent to 27b to the 3rd plus 9th power. So this is going to be 27 times b to the 12th power. Okay? So C is our answer for number 2. All right, now let's go and look at number 3. This one got a little bit longer here. Okay, So the first thing I want to do is get rid of any parentheses. So I'm going to distribute this 0 in to each of my terms here. I'm just going to go and make a copy of this so that I can write below it. Okay, so that's the problem. So now I have, let me make this a little bit smaller. All right, so now I still have the 6vu squared here times, now this is going to be 4 to the 0 power times u to the 3rd power times the 0 power, and then times v to the 3rd power times the 0 power. So I'm just going to keep on simplifying. So 6vu squared stays the same. 4 to the 0 power is just 1. U to the 3 times 0 is u to the 0. And v to the 3 times 0 is v to the 0. 3 times 0 is 0. Now again, 1 times u to the 0 power, anything raised to the 0 power is 1. V to the 0 power is 1. So this one, once again, 6vu squared times 1 times 1 times 1 is just equal to 6vu squared. Okay? So don't let those trick you. Be very careful with how you simplify. Always go step by step. But do remember that anything raised to the 0 power is just 1. So technically, all of this here is raised to the 0 power. So I could have skipped all of this work here and just said, well, this whole thing here is just equal to 1. So I have 6vu squared times 1 is 6vu squared. But I want you all to get really good at distributing the powers like this, so that's why I did it that way. Okay, so let's see number 4. Okay, so here's one where we definitely need to distribute the powers. So here I have distributing to the 4 and then to the n. Okay, and then over here I'm distributing to the 3, the m, and the n to their exponents. So once again, I'm just going to make a copy. Paste that here. All right. So now this is a little bit simpler than the other one because all of these exponents are just 1. So multiplying everything by 1 is just going to be itself. So this becomes 4 to the 3rd power times n to the 3rd power times 3 squared times m squared times n squared. Okay? And now I like to start to group. All right? So one thing I'm going to do before I group actually is simplify the ones that I can actually evaluate. So your numbers, you cannot evaluate the variables because you don't know what m equals and you don't know what n equals. But if I were to put 4 cubed, 4 to the 3rd power here into my calculator, that equals 64. Okay, so now I can go back and say, okay, I know 4 cubed is 64. 3 squared, hopefully you can do that in your head. 3 squared is just 3 times 3, so it's 9. Okay, 3 squared. Or, of course, you could use your calculator for now. 3 squared is 9. Okay? And then I still have m squared and n squared. So now I like to group, and I always like to use color for that. So I know my numbers, I have 64 and 9. For n, I have n cubed and n squared, and then the m squared is all by itself. So I'm going to rewrite these now. I can rewrite these as 64 times times 9, and then times m squared. I'm just going to go in alphabetical order. The m comes before the n, but you'll notice in the answers above it won't really matter. But let's see what we get. And then I have n cubed times n squared. So first of all, let's go ahead and do 64 times 9. Okay? So if I do 64 times 9, I get 576. And then m squared, there's nothing to combine it with. But n cubed times n squared. This is the same as saying n times n times n. That was the n cubed. And then times n squared is n times n. So altogether, I'm multiplying 5 n's together. So this is equal to n to the 5th power. You could have also just done n to the 3rd plus 2 is n to the 5th. So since we were multiplying these n's together, you add the exponents. Whenever you're multiplying the bases together, you are adding their exponents if it is the exact same base. So this is just n to the 5th. So now I want to start looking at my answer choices. And I see here that only one of them is 576. But then I'm like, wait a minute. Mine says m squared n to the 5th. And that is okay. You can rewrite this here as 576, and you can put the n first. It is still equivalent because it is multiplication. So with multiplication, it does not matter the order. However, if I had written this test, I would have made sure that the m goes before the n just because that is the alphabetical order. However, right now we're focusing on simplifying exponents. So the order is not as important as you knowing how to simplify correctly. So for this problem, C is our correct answer. Okay. So now let's go and do number 5. We have division. This one might look pretty intimidating. Okay. Here's what we do. The first thing is to get rid of those parentheses. So we're going to go and distribute this into the parentheses. Okay. And here, I'm going to do a different color there. And we're going to distribute this one into the parentheses. Okay. So now this equals, so the top one is 3 to the 3rd power times x to the 3rd, and I have to multiply it by that power, 3 on the outside here, and then times y to the 3rd times 3 as well, because we distributed that extra power on the outside. Now down here, this one just stays the same for now. We have 5yx squared, but we are distributing this 3 in, so we don't need the parentheses. We have 5 to the 3rd power times y to the 3rd power times x squared, also raised again to the 3rd power. So now we can start to simplify a bit, okay? So up top, 3 cubed is 3 times 3 times 3. And if you cannot do that in your head, please use a calculator. So we do 3 raised, nope, not squared. 3 to the 3rd power is 27. Again, that is the same as doing 3 times 3 times 3. You get 27. So the top is 27. And then here we have 3 times 3 for the x's exponent. That's going to be x to the 9th. And we also have 3 times 3 for the y's exponent. So that is y to the 9th power. Okay. Now down below, I see here that we could start grouping. Okay. I see that we have a 5 times a 5 cubed. So let's just focus on that part there. 5 times 5 cubed. Well, you could just put that directly into the calculator. 5 times 5 to the 3rd power. But I also want you to realize that this 5 here, the first one, is raised to the 1st power. So that would give us the exact same answer, right? 5 is equal to 5 to the 1st power. So if we add the exponents there, 1 plus 3, we're going to get 5 to the 4th power. And that is again equal to 625. So I want you to start realizing what you can do with exponents just like that. So here I could rewrite this as 5 to the 4th because this is 5 to the 1st, 1 plus 3 is 5 to the 4th power, which is equal to 625. So on the bottom here, I could put 625. Okay. So I just wanted to take care of those. Now we can start to rewrite. We have y times y cubed. Y times y cubed. If we were to take these over here, this is the same as y to the 1st times y to the 3rd, which is equal to y to the 1 plus 3, which is y to the 4th power. Okay, so that is those two simplified. Now here I have x squared times x to the 2 times 3. Now the only reason why I'm combining everything like this is because it's being multiplied together, not added. With multiplication, we can combine exponents like this. Okay? So I'm going to make this just a little bit smaller. There we go. All right. So the x's here, if I were to bring them over, let me use different colors. Sorry. Okay, we have x squared times x to the 2 times 3. All right, well, I would definitely simplify this 2 times 3 first. So this is equal to x squared times 2 times 3 is 6, so it's x to the 6th. And now since those two bases are being multiplied, we can add their exponents. They're the exact same base, so this is equal to x to the 8th power. Okay? So now we have this as, oh my goodness, my hands are not working. X to the 8th power. Now we are not done. We have both x's and y's on the top and the bottom. So let me just go in and take a copy of this. Now we need to simplify even more. This needs to be simplified. Okay, so the way we do this is it looks like our fraction is going to stay the same, all right? If you were trying to divide 27 divided by 625, let's see what we get. 27 divided by 625. We get a decimal like that, okay? So we don't want to do anything with that. So we're going to leave the 27 over 625. Now on top here, we can use our quotient rule where we will subtract the top from, or the bottom from the top. So the first thing I see is here, we have our x's. So this could be x to the 9th minus 8. And then we have our y's. Okay? This would be y to the 9th minus 4, the top minus the bottom. So now if we simplify this, let's see what we end up with. 27 over 625. 9 minus 8 is 1, so we have x to the 1st power. Y to the 9 minus 4 is y to the 5th. X to the 1st power is just x. So this is equal to 27x y to the 5th all over 625. And this is your answer. So our answer here is A. Okay, for number 5, our answer is A. All right, number 6. Here's another one with division. So the first thing we do here is distribute my exponent. So this will be 5 squared times b to the 3rd times 2. And I'm just going to go ahead and highlight this. So this 2, I'll highlight wherever my 2 comes into play. Times 2 squared times a cubed times 2, that was my outside, times b cubed times 2. Okay, and it's all over 6b. The 6b has nothing attached to it, right? It's all by itself. So now we can simplify this a little bit more. Let me make this a little bit smaller. Okay. 5 squared, right here, 5 squared, that is equal to 25. 5 times itself is 25. B to the 3 times 2. 3 times 2 is 6, so it'll be b to the 6th power. 2 squared is 4. 3 times 2, so a to the 3 times 2 is going to be a to the 6th power. And b to the 3 times 2 is also going to be b to the 6th power. All over 6b. So now here's where we want to start rearranging and grouping. I see I have 2 constants up top. Okay, so I'm going to go and write those first. So I have 25 times 4. Right? And then I see that I have 2 b's up top, 2 terms with b's here. So this is going to be b to the 6th times b to the 6th. And then I have this a to the 6th there. A to the 6th. All over 6b. Okay, now if I were to classify this, obviously the b would go with the other b's, the 6 would go with the green. Let's just keep on simplifying. So now I have 100. 25 times 4 is 100. Times, so b to the 6 times b to the 6. Since they're being multiplied, we're going to add the exponents. So this is b to the 12th. And then times a to the 6th. There's nothing to simplify here. It's already done. All over 6b. So we do want to realize here we have b to the 12th and b on the bottom. We have to do something with that. We can also look at 100 over 6 and see, okay, can we simplify that? So let's just think of 100 over 6 as its own fraction. Can we simplify this fraction any further? Do those two numbers have any common factors? They do. 100 divided by 2 and 6 divided by 2. Those are the common factors, 2. So 100 divided by 2 is 50. 6 divided by 2 is 3. So now I have 50 and 3 as my numbers. Now this b to the 12th over b. This can be rewritten as b to the 12th minus 1. Because this is b to the 1st power. So this is b to the 12th minus 1, okay? And then we still have an a to the 6th up here. So now let's see here, b to the 12 minus 1, that would be b to the 11th power times a to the 6th all over 3. So what is my answer? This one is A. Now, these are harder than what you're going to see on your Chapter 8 exam, but on your pre-test, you might see some that are more complex, but hopefully this video helps you out with simplifying those. All right, let's go and look at number 7. So this is another power that we have to distribute here to each variable and each number, even the one on the bottom, okay? So this is equal to y to the 3rd times 3. And again, I'm going to go ahead and highlight anytime I'm multiplying by that outside power, times 2 to the 3rd, outside power, times x to the negative 3 times 3, times y to the 3rd times 3. So there's a lot of simplifying. And this is all over x to the 3 times 3. All right, so let's keep on going. Make this a little bit smaller. Okay, so here now I have y to the 3 times 3 is y to the 9th. 2 cubed is 2 times 2 times 2 is 8. Again, you can use a calculator. Negative 3 times 3 is negative 9. And positive 3 times 3 is positive 9. And then on the bottom here we have x cubed times 3. 3 times 3 is positive 9. Now I'm going to start to regroup them, or reorder them. I always put my numbers first. And then let's go ahead and put our y's together. This is y to the 9th times y to the 9th. And then I notice that I have a negative exponent up here. It's not good. I want to flip that down below. So now this is going to be x to the positive 9 times x to the positive 9. So anytime you flip a base with an exponent over to the denominator or back up to the numerator, your exponent becomes the opposite sign of what it was before. So by doing this, I made that negative 9 up top a positive 9 on the bottom. Okay? So now I can simplify a little bit better. This is 8 times y to the 9 plus 9 power. Since they're being multiplied here, we can add the exponents all over x to the 9 plus 9 power. So this is equal to 8 times y to the 18th power, 9 plus 9 is 18, over x to the 18th power. And that is all we can simplify. There's nothing more that can be reduced. There's no more exponents that could be combined in any way. So that is all we can do for that problem. So your answer here is C. Okay. Now let's see number 8. Now we have more negatives. Okay. So here again, the first thing you want to do is distribute any powers that are on the outside of parentheses. So here I have 6 to the 3rd power times v to the negative 2 times 3 power. Okay, and that 3 is only distributed up top because the bottom does not have the same parentheses around it. So again, the highlighted red 3's are the ones I distributed. So now on the bottom, I just have 2v to the negative 1 times v. So there's a few different things we can do. The first thing I want us to do is to start simplifying the top. 6 to the 3rd power is the same as 6 times 6 times 6. Okay, so 6 to the 3rd power, again, is 6 times 6 times 6. I'm sorry if you can hear the construction in the back. They're doing something very loud outside my door. So we have 216. And that was from this value here. Now we have times v to the negative 2 times 3. So v to the negative 2 times 3 is v to the negative 6. All over 2. Now look at here. We have 2 v's here. Okay? There's a few different things we can do. You could first flip all the negatives. That is one thing I've seen students do. Or you can add them together here. Let's go ahead and do what I've seen most students do, which is flip any of the negatives. So I'm just going to write this out like normal for now. And I notice that I have 2 sets of negative exponents, here and here. So I'm going to take all of this one and flip it down to the denominator. And then I'm going to take all of this one here and flip it up to the numerator. And once you flip them, the exponents are all positive. So here now I still have 216, And I'm going to squeeze in that v to the negative 1 is going to become v to the positive 1. All over, I still have that 2 down there in the regular v. And now I'm also flipping down the v to the negative 6 to make that 6 a positive 6. So now this looks a little bit nicer. My students have always liked seeing positive exponents instead of negative exponents. So now we could start to combine. So up top we don't have any v's to combine, just one v. But on the bottom here I have v to the first power times v to the sixth power. If you add those two together, 1 plus 6 is 7. You could also write these out if you still are not seeing how to use the rules. If you write these out, you ask yourself, okay, how many v's are being multiplied together? There are 6 v's being multiplied together. So we have 2 times v, or I'm sorry, there are 7 v's being multiplied together. 2 times v to the 7th power. Okay. Now we're almost done, but we have to do a final simplifying step. All right. I still have v's on both the numerator and the denominator. And I also want to see, can we divide 216 by 2? 216 is an even number, so I should be able to get a whole number if I do 216 divided by 2. And I do. I get 108. Okay? So I get 108. And then the v's here, I can use the quotient rule. This is really v to the first power. If there's no exponent, it's always to the first power. So this is equivalent to 108 times v to the 1 minus 7 power. If it's being divided, then you can subtract the top exponent minus the bottom exponent. So this is equal to 108 times v. What is 1 minus 7? You can use your calculator. 1 minus 7 is negative 6. So this is 108 times v to the negative 6th power. Now, if you look at your answer choices, you're not going to see that option. Okay? So we have 108 times v to the negative 6th power. I hope you guys remember, if you have a negative exponent, you need to flip that down or back up to make it a positive exponent. So now this would be your final answer here. And that is D. Okay, on your test, you're only going to have, I believe, 5 exponent problems, and they should be faster than these, okay, just to give you a little heads up. Okay. Number 9, it says use simple interest to find the ending balance. Well, first of all, let's jot down some formulas here. For interest, this is equal to the principal times the rate times the time. Okay, so this stands for interest equals principal, which is otherwise known as the starting amount, times the rate, and you do not want a percent in there, so you have to convert it from a percent to a decimal usually, times the time. That is how you calculate the interest. Now, to find the ending balance that this wants, that's basically to find the total. Ending balance. What we have to do is we have to take our principal, which is the starting balance, and add the interest to it. So we have to go back to our principal and add the interest to find our ending balance. Okay? So this is really, really important and what we're going to use to solve these next 2 problems. So I'm going to go and make a copy of this. There we go. All right. So here it says $20,400 at 5% for 2 years. Well, even though it doesn't state it explicitly, this is the principal. And this will look the same on your test, so keep an eye out. That is the principal. 5% is my rate, but it needs to be out of 100%, or you just move the decimal back 2 times. So to rewrite this as a decimal without a percentage, we can do 5 divided by 100, and you get 0.05. That is the same thing if you had moved the decimal over 2 times to the left. So our rate here is 0.05. Our time is 2 years. It's our time. So let's find our interest. Interest is equal to PRT. So in this case, my interest is equal to, my principal is 20,400, times my rate, which is 0.05, not 5. It has to be rewritten as a decimal, times my time. This will tell me my interest. So let's go and use a calculator for that. Definitely you were not expected to do that in your head. Use a calculator. Okay, so we have 20,400 times 0.05 times 2. Our interest over 2 years is $2,040. So my interest is $2,040. That is not the answer. You guys see here, B is that. That is not the answer because it's asking us for the ending balance, not the interest. We need to use the interest to find the ending balance. Do not let that trick you, okay? So the ending balance is equal to the principal plus the interest. So my principal was 20,400 and my interest is 2,040. So if we add those two together in our calculator, we can do 20,400 plus the answer from above, 2,040, we get 22,440. So our total is 22,440. So our answer is C. Make sure you're reading the numbers very carefully, okay? A lot of them look similar. All right. Number 10. Okay, so we're going to use that same method here. Same notes as before. You don't have to rewrite it again, but just know that that's what we're using. So first we have to identify our principal. This 11,800 is the principal. Okay. Then the rate is 4%, but we have to write that as a decimal. How do we do that? You can move the decimal to the left 2 times, or you can just do 4% divided by 100%, 0.04. So my rate here is 0.04, and that's what you have to use in your formula. The time is 2 years, so this is time. Okay. Now first I have to find the interest before I can find my starting balance. So I know that this is the interest formula. Oop, that's not what I wanted. There we go. Okay, so interest is equal to my principal, 11,800, times my rate, which is 0.04, times my time, which is 2 years. again, I would use Desmos scientific calculator to calculate that amount for you. So this would be 11,800 times 0.04 times 2. 944. So our first step is done. Calculate the interest. 944. Done. Now to find the total or the ending balance, this is the principal plus the interest. Now we just found that the interest is 944. That's what all that work was for, was to know that. Now the principal was 11,800. So we need to add those two together to get the total amount for our answer. So we have 11,800 plus 944. We get 12,744. Okay. This should be your answer. You guys notice here, D, that was the interest. But it's asking for the ending balance. It did not say tell me the interest. It said what is the ending balance. So our answer is B. Okay. So make sure that you've paused throughout this video to take notes. Okay, oops, sorry. All right, this is the new one. We are just going to use a formula. All right. So the formula we're going to use, let me see here. So, perfect. Okay. So this is the formula. We have A equals the principal times 1 plus my rate over N. This is a new one. Over N. Raised to the N. Trying to remember what color I used for T. What color did I use for T? Oh, I used green for T. Let's change the color of N. Sorry. We'll do gray for N. Times time. All right. Whew. Okay, so the principal here is P. So P is principal, which is your starting amount. R is still your rate. N is the number of times per year. And I'll explain what that means in a minute. Number of times per year. T is time. Now, normally in class, we will learn why we do it this way. But for this case, I'm just going to use the formula. This is for compound interest. Okay. Compound interest. So, first things first is to identify all of the parameters. So, A is our amount. So, our total amount is what we're solving for. So, we're always going to solve for A in this case right now. So, we have A equals our principal is 52,200. Okay. And then our rate, the R, is 6%. So 6%, 6 over 100, or move the decimal back 2 times, is 0.06. So our rate is 0.06. So we're going to do times 1 plus my rate, 0.06, divided by N. What is N? Compounded annually for 7 years. N in this case is just 1. compounded annually, that means once a year. Okay, that is the gray part. So that's really nice. It kind of makes our job way easier. So this is compounded once a year. Annually means once a year. So it'd be raised to the 1, which won't really change it, times t. Our time, what is my time? It's 7 years. Times 7. Okay. There we go. That looks more like multiplication. So, guys, literally you can plug exactly this into your calculator. You could just simplify it on your own, but we could plug this exactly into our calculator. So here, if I go to my calculator, I'm going to do 52,200 times, using the parentheses, 1 plus, let me see here, it was 0.06 divided by 1, and then I go out to my parentheses again, and it's raised to, you use the little a to the b power, it's raised to the 1 times 7, whoops, you see there how it didn't stay? I needed it to stay up in the exponent, times, it's not wanting to do it, maybe if I put parentheses there, 1 times 7 power, there we go. So you can always put parentheses there to hold it where it needs to be. So this is how it will look in Desmos, so keep this in mind. 78,489.49952. So let me go write that down. So this equals I'm going to also put this in our notes there, just so you guys can see how you would enter it into Desmos, okay? So let me paste that in here. Oh. There we go. So this is how I typed it into Desmos. To be very careful. So it is 78,489.499 and then 52. All right. So now let's look at our answer choices and see which one it is. It's number 11. Yeah, so we should get A. Okay, so our answer here is A. Sorry guys, I know this is probably getting to be a pretty long video at this point. My throat hurts. Okay, so we're going to do the exact same thing. I'm just going to copy this. You do not have to write it down again. There we go. All right. Here we go. So we want to find the total amount. First, I need to know what the principal is. 41,300. Okay. Now I want to know what my rate is. So it times 1 plus R. R is on top. So my rate is 14%. 14 out of 100 is 0.14. Okay, percent to decimal, 0.14. Now it says the number of times per year. Okay, this one's a little bit different. This one says semi-annually. That means 2 times a year. 2 times a year. So that's where this is super important. So our N is 2 there in that formula. Just to remind you, this is the formula I'm using right here, okay? So now this is raised to the 2 times the t power. What is t? 4 years. 4. So once again, we can plug that directly into Desmos. If you have problems with putting in this exponent, we know 2 times 4 is 8. So you could always put 8 instead. It's totally up to you. So this is going to be 41,300 times 1 plus, I have 0.14 divided by 2 raised to the, I'm going to put parentheses, 2 times 4 power. You should get the exact same thing if you change that 2 times 4 power to an 8. So let's see here, 0.14 divided by 2, and then raised to the 8th power. We get the exact same answer, okay? So here we have 70,961. .08923. Of course, we would round it because it's talking about money, but this just kind of helps me see what is my answer. Our answer here is going to be B. Okay. This 9 here bumps up this 8 to a 9. So rounded to the nearest hundredth, it would be 70,961.09, or 9 cents. This is compound interest, and this is the only new thing. Everything else is still just practice, right? This is the only new thing. Now we're moving on to some review. My throat is killing me, but I'm going to push through for you guys. All right. So here we have, I'm not going to go very slow either because I'm trying to finish this so I can drink some water. All right. So first thing I would do is draw my line. Distribute first. I recommend pausing the video and trying this out on your own. You should be able to do these. So now I'm going to get all of my X's over to one side, or my R's. I guess this time this is an R. Does not matter which side you go on. Okay, I'm just going to do this so that you guys can see what the answer should be. I chose to move my R to the right side was just to get rid of that negative. And then I end up with more negatives. But, so negative 35 minus 37. That one was? Yep, negative 72. It's going to be negative 3. So you guys should get negative 3 for this one. This one is D. So again, make sure you do this on your own, but I just wanted to show you what it is. But you should be doing these on your own. And then checking your work. So same thing for this one. Do not watch this until you've tried it on your own. Okay? I'm definitely giving my voice a rest. That's why I'm not talking. Since this is review, that's why I'm doing this so fast. This one's interesting. Negative 2 plus 2 is 0 equals 3n. Divide by 3. 0 divided by 3 is 0. Our answer is n. It's A. So if you're like, wait, what? How does that even work? You can test it. So this was our original equation. We can test this to be 0, and let's see if it's true. So we're just going to change all the n's to 0. We just want to see, is it true? So negative 2 plus 0 is negative 2. Here I have 2 minus 4 times 0 is minus 0. So again, these are all question marks. 2 minus 0 is just 2. Does negative 2 equal negative 2? Yes. Okay, so plugging in 0 made it true. So that's why our answer here is A. All right, we only have 2 more. Okay. Y equals mx plus b. This should be quicker. The m, slope, which is rise over run, plus b, it's your y-intercept, where x equals 0. It's your starting point. I always like to find the y-intercept first. My y-intercept here is negative 1. Okay. So if I take this, my b here is minus 1. Now I can draw a slope triangle to the next lattice point there. See that? I went up 2 to the right 1. Up 2 to the right 1. So my rise is 2, my run is 1. So my slope, 2 divided by 1 is 2. So y equals 2x minus 1. That would be my final equation. The answer here is D. So definitely review these if you've forgotten how to do this. Ooh, this one's tricky. I wish I would have seen this. I would not have done this for you. But if I ever see a straight line, I start to write out the points. This one is negative 1, negative 1. This one is 0, negative 1. This one way over here is 5, comma, negative 1. This one is 3, comma, negative 1. This one is negative 3, negative 1. This one is negative 5, negative. So what do they all have in common? The y-coordinate on every single one of these is negative 1. Therefore, y equals negative 1. That's kind of a bummer, I'm sorry. You should not see that on your test, but just in case you ever do, this is how I do those. Okay? This one has no slope, and it crosses through negative 1, so that's why it's y equals negative 1. All right, that is it. Hopefully you got through this whole video. Now you have a test. It's basically a quiz